students. Very good morning to all. Today we have to discuss about d block elements. Okay. What are the d block elements? The last electron enter into the d subshell. In those elements, the last electron enter into the d subshell. That elements are called d block elements. In periodic table, these d block elements are placed in between s block elements and p block elements. Okay, so these d block elements properties also between s block elements and p block elements. That's why these d block elements are called transition elements. Transition elements. Okay. What are the transition elements? Means those d block elements incompletely filled off d subshell. Those d block elements incompletely filled off d subshell. That is called transition elements. D1 to 9 incomplete. D completely filled means D10. So those elements, their electronic configuration exists D1 to 9. That elements are called transition elements. For suppose zinc D10, cadmium D10, mercury D10. So zinco, cadmium, mercury we cannot call transition elements. Only we call d block elements. Transition elements means D1 to 9 configuration only. Okay, that's why all d block elements belongs to transition elements, but all transition elements all transition elements belongs to d block elements, but all d block elements but not belongs to transition elements. Okay, then in periodic table, d block elements having 10 groups, that is 3d, 4d, 5d, 6d, 7d, is 8, 1, 2, 3, 1d, 2d. Totally 10 groups present in periodic table between s block elements and p block elements. Okay, next one. Generally, d block elements having 3 series: 3d series, 3d series from scandium to zinc, atomic number 21 to 30. Here some last subshells are 3d, 4s or 4s, 3d. Both are correct. 4s, 3d. Next, 4d series. 4d. Next one, 4d series. Yttrium 39 to cadmium 48. Okay, here valence shells is 5s, 4d. Next, 5d series. Lanthanum 57, hafnium 72 to lanthanum 57, hafnium 72 to mercury 80. So lanthanum, hafnium to mercury. Here 6s, 5d. Okay. Generally d block elements having 3 series: 3d series, 4d series, 5d series. Scandium to zinc, atomic number 21 to 30. is called 3D series. Valence shell 4s comma 3D. Next 4D series, yttrium to cadmium 39 to 48. 5D series, lanthanum comma hafnium to mercury 72 to 80. Atomic number 72 to 80. So valence shells are 6s comma 5D. 6s comma 5D. So here D block elements having maximum all D block elements having similar physical and chemical properties. What is the reason? So all D block elements having similar physical and chemical properties. Okay, due to expansion of electrons in penultimate shell, expansion of electrons or expand of electrons in penultimate shell. Penultimate shell means last one. So but last one. Okay. So here which is penultimate shell in D block elements? N-1D. N-1D NS. NS is the valence shell. NS is the valence shell. N-1D is the penultimate shell. N-1D is the penultimate shell. NS is the valence shell. Okay. What are the different properties in D block elements? First one, D block elements are hard metals, different characters. Hard metals, they having different characters, that is ductile nature, tensile strength. Okay, next one. D block elements exist variable oxidation states. Due to small atomic size and having vacant d orbitals. Third one, import different colors. Next, having high melting and boiling points. Having high melting and boiling points. Having high enthalpy of atomization. Next one, last one. It is enthalpy of atomization, melting and boiling point. Having different existence, different magnetic properties. These are the different characteristics in D block elements. Why D block elements exist different characteristics? Reason. First of all, D block elements are small atomic size than even S block elements and B block elements. D block elements having vacant orbitals. That's why D block different characteristics. Another thing, d block elements having unpaired electrons. D block elements having unpaired electrons. Due to unpaired electrons also, D block element shows high melting and boiling point, high enthalpy of atomization. So small atomic size, having vacant orbitals and having unpaired electrons. Due to these reasons, D block element shows different characteristics. Next one by one properties we have to discuss. First one, atomic radius or ionic radius, no problem. Atomic radius. For example, in 3D series we observe generally in periodic table along the period from left to right atomic radius decreases. What is the reason? Nucleus charge increases. Due to nucleus charge increases, atomic radius decreases from left to right. Okay, along the period. Already you know. So in 3D period, 3D series, scandium, titanium, next vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. In 3D series, scandium to manganese, atomic radius decreases. Atomic radius decreases. Then iron from manganese to nickel, that means iron cobalt to nickel, atomic radius neither decreases nor increases, remains constant. Remains constant. Slightly increases, gradually increases. Just gradually increases. Gradually increases. Then nickel to copper, copper to zinc, but again atomic radius increases. Atomic radius increases. Okay, what is the reason? Here, scandium to manganese atomic radius decreases due to nucleus charge. Nucleus charge more effective. Nucleus charge dominated than screening effect. Screening effect. What is the screening effect? Already we discussed in 11th classification of elements chapter. Screening effect means due to repulsions of inertial electrons, nucleus charge very less effective on valency shell electrons. Okay, at that time less effective nucleus charge decreases due to repulsions of inertial electrons. So that's why effective nucleus charge decreases or less on the valency shell electrons, while it leads to atomic radius increases. Effective nucleus charge decreases. That is screening effect. Here nucleus charge greater than screening effect. Here remains constant means here nucleus charge equal to screening effect. Nucleus charge equal to screening effect. Next, in copper zinc atomic radius more. That means here screening effect dominate nucleus charge. Screening effect dominate nucleus charge. That means your screening effect greater than nucleus charge. This is the atomic radius various in 3D series. Same 4D series also, 5D series also. First initial to half of the period increases. Then half of the period to end of the period, first gradual increases, end of the period more increases. What is the reason means? Till half of the period radius because last two elements spinning effect fully dominated the nucleus charge. That's why the atomic radius is expansion mode. Okay. Then in groups, that means atomic radius already knows in groups top to bottom increases. That's why 3D to 4D, 4D to 5D atomic radius increases. Atomic radius increases. But 4D, 5D, 4D, 5D having nearer atomic radius values. 4D, 5D having nearer atomic radius values due to lanthanoid contraction. Due to lanthanoid contraction. Okay. This is about the atomic radius. Next one, ionization energy. Ionization energy. Right. Generally we know in any period along the period ionization energy increases from left to right. So here also 3D, 4D, 5D any period from left to right ionization energy increases. 4D also left to right ionization energy increases. 5D also ionization energy increases. Along the period from left to right ionization energy increases. The group 3D to 4D, 4D to 5D, 3D to 4D, 4D to 5D ionization energy decreases. Already we know why in groups top to bottom ionization energy decreases due to atomic radius increases, nucleus charge decreases. Okay, this is about ionization energy. Next, another one important one, melting and boiling points. Melting and boiling points. Melting and boiling points. Generally, D block elements melting and boiling points more than S block and P block elements. D block elements melting and boiling points more than S block elements due to strong metallic bond formation. D block elements strong metallic bond formation. Strong metallic bond formation. Strong metallic bond formation. That means strong interactions is there. Strong interactions is there. Strong interactions is there. Why strong interactions is there? Or why D block elements formation? Strong metallic bond. Simple reason, due to unpaired electrons present. Due to unpaired electrons present. Due to unpaired electrons present, D block elements formation strong metallic bond. Okay, due to strong metallic bond, D block elements having more melting and boiling points than S block elements. First of all, D block elements formation strong metallic bond. So what is the reason? Due to unpaired electrons. Due to unpaired electrons, D block elements formation strong metallic bond. Strong metallic bond. Okay. Next one. Due to strong metallic bond, D block elements having more melting point and boiling points than S block elements. Due to strong melting and boiling point, due to strong metallic bond, D block elements having more melting and boiling point. More melting point and boiling point. Okay. How does melting and boiling point variation across the period? For example, 3D series we take it. Right. Scandium to titanium increases, titanium to vanadium, vanadium to chromium, but again manganese decreases, manganese to iron increases, iron to cobalt somewhat decreases, cobalt to nickel decreases, nickel to copper decreases, copper to zinc more decreases. Okay, because here unpaired electrons, here 1 unpaired electron, here 2, here 3 unpaired electron, okay, here 4 and here 5 unpaired electrons, here also 5, okay, here iron, iron 4 unpaired electron, cobalt to 3 unpaired electron, nickel 2, copper almost 3d10 4s1 means 0, copper in stable state means 0, zinc also 0 unpaired electrons. That's why scandium to chromium unpaired electrons increases. Scandium to chromium unpaired electrons increases. That's why chromium 3d okay. Scandium to chromium unpaired electrons increases. That's why melting and boiling points increases. Manganese also 5 unpaired electrons in there, but expecting to be observing manganese melting and boiling points less only. So we observed when we can observe more values from manganese, but manganese having less melting and boiling points only due to manganese having high ionization energy values. High ionization energy values. Here Lidama, manganese although 5 unpaired electrons, manganese although 5 unpaired electrons, okay, less melting and boiling points. What is the reason means? Manganese due to high ionization energy values. Ionization energy values. Due to high ionization energy values, manganese has low melting and boiling points, although having 5 valency, 5 unpaired electrons. Then iron to nickel gradually decreases. Copper zinc less melting and boiling point. What is the reason? Copper and zinc does not have unpaired electrons. Copper and zinc doesn't have unpaired electrons. So this is the melting and boiling points. Next one, enthalpy of atomization. Enthalpy of atomization. Enthalpy of atomization. Generally, d block elements enthalpy of atomization more than s block and p block elements. Generally, d block elements enthalpy of atomization more than s block and p block elements. Reason: due to unpaired electrons present. Due to unpaired electrons present. Unpaired electrons present. Due to unpaired electron present, d block elements enthalpy of atomization values more than s block and p block elements. What is the reason? Due to unpaired electrons present. Which element having more unpaired electrons, that element enthalpy of atomization more. For example, zinc, cadmium, mercury. Zinc, cadmium, mercury, enthalpy of atomization very less. Enthalpy of atomization, enthalpy of atomization less only. Okay, what is the reason? Zinc, cadmium, mercury does not having That's why enthalpy of atomization depends on the unpaired electrons. Okay, this is the enthalpy of atomization. Next, electronic configuration. Electronic configuration. First, general electronic configuration of d block elements. General electronic configuration n minus 1 d 1 to 10 ns 1 to 2. This is the general electronic configuration of d block elements. N minus 1 d 1 to 10 ns 1 to 2. Except palladium. Okay, palladium configuration 4d10 5s0. Only palladium having s0 configuration. In total d block elements, palladium only having s0 configuration due to stability. Okay, this is the general configuration of d block elements. Okay, now 3D series we have to discuss electronic configuration values. Very important. 3D your syllabus 3D series only giving. 3D series electronic configuration. Scandium 3D series. Scandium. What is electronic configuration? Argon 3d1 4s2. Titanium argon 3d2 4s2. Vanadium argon 3d3 4s2. Chromium argon 3d5 due to half-field configuration 3d5 4s1. Next, manganese argon 3d5 4s2. Iron argon 3d6 4s2. Iron. Next, cobalt 3d7 4s2. Nickel 3d8 4s2. Copper 3d10 4s1. Zinc 3d10 4s2. Okay, these are the electronic configuration for 3D series. So in further topics also useful, you should learning 3D series elements electronic configuration perfectly. Then another one you should knowing, for example, scandium 3d1 4s2. Scandium plus 1 means electron loose from 4s1. That means 3d1 4s1. Scandium 2 plus 3d1. Scandium 3 plus 3d0. Like titanium 3d2 4s2. 3d2 4s2. For example, titanium plus 1 3d2 4s1. Titanium plus 2 3d2. Titanium plus 3 3d1. Okay, titanium 4 plus 3d0. First electron eliminated from 4s shell. After that electron eliminated from 3d shell. Like that, for example, chromium. Chromium should learning about this one. You should learning chromium 3d5 4s1. Chromium plus 1 3d5. Chromium plus 2 3d4. Chromium plus 3 3d3. Chromium plus 4 3d2. Chromium plus 5 3d1. Chromium plus 6 3d0. You should learning about this one. You should knowing. Okay. For example, manganese 3d5 4s2. For example, I want manganese 3 plus. Manganese 3 plus means 2 electrons eliminated from 4s, 1 electron eliminated from 3d5. That means 3d4. Correct now? For example, I want manganese 6 plus. Manganese 6 plus. 2 electrons from 4s, 4 electrons from 3d. That means 3d1. Manganese 7 plus. 3d0. Like that. Next, iron. Iron 3d6 4s2. For example, iron 2 plus, Fe2 plus 3d6, Fe3 plus 3d5. Like that. Okay. Next, cobalt 3d7 4s2. Cobalt 3 plus. I want this cobalt 3 plus. 2 electrons from 4s, 1 electron from 3d. 3d6. 3d6. Only cobalt 2 plus means 3d7. Next. Next, nickel. Nickel 3d8 4s2. Nickel 2 plus 3d8. Like that. Next, copper 3d10 4s1. Copper plus equal to 3d10. Copper 2 plus equal to 3d9. Okay, like that. Zinc 3d10 4s2. Zinc 2 plus equal to 3d10. So like that, minimum 3d series configuration you should learning about. So you should learning 3d series electronic configuration, and also iron 3 plus equal to what configuration? Iron 3 plus means immediately you tell 3d5. Cobalt 2 plus immediately you tell 3d7. Cobalt 3 plus immediately you tell 3d6. Chromium plus 2 immediately you tell 3d4. Because further complex compounds, D block elements also magnetic properties, color properties time very useful. Further coordination chemistry, complex compound chapter also, these configurations are very important. That's why everyone should practice and also should learning. Okay students, thank you.